So, looking at lesson 8.4, okay, and what I was starting to say is that we're taking a slightly different direction in that we are looking at rational expressions this chapter. Rational. What's rational mean again? If something is rational, it can be expressed as a fraction. See, if I give you that lead in, it's all easy, right? Okay, so rational expressions are expressions that are expressed as fractions. So, as we are working through 8.4, 8.5, and 8.6, it's all about rational expressions and eventually solving rational equations. So, our job today is we're just learning how to simplify these rational expressions. And then while we're simplifying, we'll also multiply and divide them because that goes right along with simplifying. Okay? So, notice up here, a rational expression is of the form P of x over Q of x, given that P of x and Q of x are polynomials. Basically, it's just saying it's a fraction form. P of x and Q of x being polynomials. If you remember a definition of a polynomial, that's when various terms are added and subtracted. Those are polynomials, okay? Now, the simplest form of a rational expression is when both the numerator and denominator have been, notice what it says, factored and reduced. So that is a big thing today, is how do we simplify these expressions? And as we try and simplify them, factoring and reducing. Factoring is a big thing, guys. We reviewed some factoring back in, 8.3? We've got a lot of factoring to do here. You've got to be able to factor to succeed in this stuff, so we'll keep reviewing that. So, for example here, x squared minus x minus 6 over x squared plus x minus 2. Notice what did not happen right off the bat. Oh, x squared, so let's cancel. Oh, x, let's cancel. Oh, 6 divides by 2 and is 3. Let's cancel. As easy as that looks, unfortunately, that's the wrong way to go. Okay? So we have to do right things, and we have to factor and then reduce. You cannot cancel pieces that are added and subtracted. Okay? So the big thing to remember is you can only factor. I think I said that wrong. You can only cancel factors. Okay, we can't cancel pieces being added and subtracted. So as tempting as it is, cancel the x squareds, we can't do that. We have to factor. And so real briefly, if you remember x squared minus x minus 6, we're going to be doing that product and sum factoring. Factors into x minus 3, x plus 2. Denominator factors into x plus 2, x minus 1. I'll review factoring when we get to some examples. What do you notice now? Yeah. No, I couldn't have canceled x squareds here because they're added and subtracted to other pieces, but a factor of x plus 2 can cancel with a factor of x plus 2, leaving us with x minus 3 over x minus 1. And that's the form a final answer will look like today. Again, no, you're not canceling those x's because this x, could I use the word married, is married to the minus 3. It's x minus 3. When they're added and subtracted, they're married together. You can't break them apart. Okay? X minus 1, same thing. Now, the other pieces we're going to have to watch for here. Notice it does say where x cannot equal 1 or negative 2. And they will talk about restrictions on the variable or excluded values. Forgot to log into Math Excel and check their terminology this morning. But if you look back right here, we're going to want to look, where do those denominators equal 0? And those are places where this expression cannot exist. Okay, so we'll talk about all of this as we go. That's kind of some of the gist of it. I already said this, but it's here in writing. Things with plus or minus signs, right? Adding, subtracting signs. I use the term they're married. You can't cancel them until they have been factored. Okay, so we have to do that factoring. Product and sum factoring is going to be a big one, but we can also think GCF, sum or difference of squares. So we'll go over a bunch of factoring. So I'm going to jump us right into example A here. And this example 1, this row is all about just simplifying. Okay, what can you do, what can't you do? And notice up above it said to factor and reduce. So as we look at A, x squared plus 7x plus 10 over x squared minus 3x minus 10. Can I cancel the x squareds? No? You've been listening to me? Okay, just checking. Just checking. Okay, so we need to factor. How do we factor something like x squared plus 7x plus 10? It's in that x squared plus bx plus c form where we can factor it into what? Two parentheses sound familiar? What do you know about x squared? It breaks into x and x. How do we determine our numbers again? Adds to be 7, multiplies to be 10. Yep. So I tend to say product of 10, sum of 7. But I'm not against Eli's words either. I try and say it both ways. So multiplying to be 10, adding to be 7. You guys came up with 2 and 5. What about the signs? Multiplies to be positive, adds to be positive. Both signs are going to be positive. Is this ringing some bells? Lots of factoring in our days ahead. Okay, what about the denominator? X squared minus 3x minus 10. Two parentheses. X squared is x and x. What do we need for numbers this time? What do they have to do? Okay. Multiply to get negative 10. Add to get negative 3. Yeah. That 2 and 5 do it again for us. You just have to change some signs here. Okay. In order to multiply, get a negative, one of them has to be negative. In order to add to be a negative, larger number is negative. So it's a minus 5 and a plus 2. Okay, we factored. Can we reduce? Can I reduce anything? Yeah. I have a common factor of x plus 2 with a common factor of x plus 2. Those can cancel. What about the others? Do they cancel? No. They have to be identical, folks. An x plus 5 is not identical to an x minus 5. So those remaining pieces is your answer to the simplification problem. X plus 5 over x minus 5. Okay. So this answers the first question of what are each of the following in simplest form. There is your answer to part A in simplest form. No other factors to cancel, so we stop there. Now, there is a secondary part here, and it says state any restrictions on the variable. Is there anything that x could not equal? And here's the deal, guys. We're dealing with fractions. What's true about the denominator of a fraction? Denominator can never equal 0. Are there numbers that might make this denominator equal to 0? There are. Okay? And the easiest thing I can suggest is to set your denominator equal to 0 to find those pieces. Now, what would be your easiest version of the denominator to set it equal to 0? In other words, do you want to use x squared minus 3x minus 10 and set that equal to 0? You could, but you're just going to end up having to what? Factor it. And so your easiest step is to take each of your factors and set them equal to 0. Okay? So denominator equal to 0 is what we're doing. And when I say denominator equal to 0, it's all parts of the denominator. Even if it got canceled, was it still in the denominator at one point? Anything that was ever part of the denominator has to be set equal to 0. So that means I'm going to set x plus 2 equal to 0, and I'm going to set x minus 5 equal to 0. Do I need to set x plus 5 equal to 0? No, because it's not the denominator. Numerator can be 0. It's just the denominator cannot. So, do your basic math. What do you know? If it's x plus 2, subtract 2. X cannot equal negative 2. If it's x minus 5, add 5, and x cannot equal 5. Okay, these are your restrictions on the variable. X cannot equal negative 2, x cannot equal 5. Because those are items that would make your denominator equal 0, which is not okay. Questions on anything I did there? Got it? Huh? It is a lot of information, and we're obviously, it's not just a one and done example. We're going to do several. Yes?
So what is the denominator equal 0?
The denominator okay, so we're setting the denominator equal to 0 to try and find any restrictions on you can't see where I'm pointing, but up there it said to find any restrictions on the variable. So is there anything that x cannot equal? And by setting, because the denominator cannot equal 0, because that just can't happen, we can't have 0 in the denominator of a fraction, we set the denominator equal to 0, and those are the numbers where this expression cannot exist. Like if I put in negative 2 right here, I ended up with 0 over 0. We can't have a fraction with 0 over 0. It's not possible. If I put in 5, I ended up with something over 5. And you can't divide, not something over 5, we ended up with something over 0. We can't divide by 0. Remember, when you do something divide by 0 in your calculator, that's when you get that lovely error. Okay? So that is just our way to find our restrictions on the variable. Okay? So if it just wants the answer, you're just giving this. It will probably, and again, I was doing other stuff this morning, I forgot to get in Math Excel and remember how it sets up. But they'll probably have like where this is a part A type thing, and then this is going to be a part B. Like you'll get, two separate answers, if I recall. Okay? Okay, let's try B. B is a little different. It's not quite your typical problem. We'll get back to more of a typical problem on C. Our job is to factor and reduce. Now, the difference here is, do we have any adding and subtracting? No. So do we have anything that's, quote, married? No. We have one term on top, one big term on top of 24x cubed y squared. We have one big term on bottom, the negative 6x squared y cubed. One term on top, one term on bottom. You can cancel anything you want. Are there pieces you see that could cancel? Are there any numbers in common? (24) and 6 could both divide by what? Can't they both divide by 6? What about the x's? Are there any x's in common? How many x's do we have on top? 3. How many x's do we have on bottom? 2. Are there any in common? They both have 2 x's, right? Because on top, when you see x to the third, think of x to the third as x times x times x. X squared is x times x. So what's going to happen? 1 x left on top, right? 2 of those x's can cancel. What about y's? Yeah, there's 2 y's on top, 3 y's on bottom. So again, 2 can cancel 1 y on bottom. Are you seeing where this is going? Now, honestly, you could just write your answer right now. I don't really have to have steps on this one. Okay? However, if you want steps and you're trying to break it down to pieces, think about the like pieces. Think about in terms of numbers. It was 24 and negative 6, right? You said that they both divided by 6. So on top, what does that leave? 24 divided by 6 leaves us with 4 on top. On bottom, what's 6 divided by 6? Well, I say 6 divided by 6 is 1. There is a negative there, though, yes? So, and in all honesty, because there's just a negative, I'm just going to put the negative out front of the fraction. I'm not going to put the 1. You can, but you don't have to. Think about x's. If I write that out as x cubed over x squared, we already talked about 3 x's, 2 x's, 2 of those x's cancel, right? Or, when there's exponents involved, officially, what can we do? Subtract, right? 3 minus 2 is 1. Where were there more x's? On top. So where is that x to the first? On top. And then if you want to think about y's. Y squared over y cubed. We already talked about 2 y's on top, 3 y's on bottom. 2 of those y's cancel, right? Where is that extra y? On bottom. If you think in terms of subtracting, what I like to say is just subtract bigger minus smaller. 3 minus 2 is 1. Where was the bigger number? On bottom, so that's where I put the y. If you subtract top minus bottom, 2 minus 3 is negative 1, and that tells me to push it to the bottom. So several different ways you guys can come up with that answer. Ultimately, the answer is negative 4x over y. That negative could be on top with the 4x. It could be in front of the fraction bar. I would accept it in front of the y. If you want to get technical, you'll sometimes be told you can't have a negative denominator. And so, if we want to be technical, it would go with the numerator out front of the fraction bar. I'm not picky personally. Okay, I'll take, as long as you get the negative in there, that's where I'm picky. Get the negative in there. Now, any restrictions on the variable, or if you hear me say excluded values. Is there anything that would make this denominator equal 0? And this one's a little different, isn't it? If what?
If y was equal to 0.
Okay. Think about this. If y was 0, you'd have 0 cubed here, right? And 0 cubed is 0 times anything is 0. So could y equal 0? No. There's one excluded value. There's another one. Y can't equal 0. And x can't equal 0, right? Because what if x was 0? 0 squared is 0, and 0 times the rest of that denominator would be 0. So again, as I said, this one is a little bit different. So in this one, if I'm talking about saying my denominator equal to 0, I don't need to worry about negative 6. It's a number. But if I worry about each of the pieces, if I set x squared equal to 0 and y cubed equal to 0. Well, officially, if x squared equals 0, if you don't see it, take the square root, right? And so then x cannot equal 0. Y cubed equals 0. Well, take the cube root if you want. And so y cannot equal 0. Those are my restrictions on the variable. Okay, only ones that are going to look like that is when you just have one big term in the denominator. Okay, when you just have, no adding or subtracting, that's the only ones that are going to look like that. Our others are going to be more the individual factors. Questions before I move on to the next one? Okay. C, x squared plus 2x minus 8 over x squared minus 5x plus 6. What do I need to try and do? Factor. Factor, factor, factor. X squared plus 2x minus 8 is in the form where we can set it up as 2 parentheses, we hope, yes? What do you know about x squared? X and x. What do my numbers have to do? Okay, multiply to be negative 8, add to be 2. What combo can we use? If it multiplies to be negative 8, adds to be 2. It's some combination of what numbers? 4 and 2. Okay, I always think some combination of what numbers, and then I'll put my signs on. If you don't have your signs on, now's the time. If it multiplies to be negative 8, we know a positive and a negative. If it adds to be positive 2, bigger numbers positive, smaller numbers negative. Okay. Denominator. Looks to be in a good factoring form, yes. X squared again breaks into x and x. This time, multiplying to be 6, adding to be negative 5. What'd you say? 2 negatives. Okay, which is helpful to, if it multiplies to be a positive, my signs are the same. If it's going to add to be a negative, then I do agree both of these have to be negative. And that means these two numbers are actually going to have to add to be 5. Which numbers am I using? 2 and 3? Common mistake here would be to say 1 and 6. Because 1 and 6 multiply to be 6 and they subtract to be 5. So you have to watch the signs here. In this case, it's 2 and 3. Okay, what do you notice? We have a factor of x minus 2 that cancels. Anything else cancels? No, so what's my answer? X plus 4 over x minus 3. You getting the hang of the simplifying? It's factor, reduce. Factor, reduce. Okay? What about, are there any restrictions on the variable? Is there anything x cannot equal? What? 2 and 3, she says? How would we come up with 2 and 3? Yeah. Set the denominator equal to 0. And notice I keep writing that in there as a reminder, yes? So if I set my denominator equal to 0, I'm setting x minus 2 equal to 0, x minus 3 equal to 0. Anything that ever is or was a denominator. I don't care that it got canceled. It was in the denominator, it counts. So, x cannot equal 2 and 3. And for our purposes on paper, I tend to do that right there. X cannot equal, so notice I put a slash to the equal sign saying cannot equal 2, 3. I don't remember how Math Excel sets it up, obviously, so. Thoughts on D? Numerator look a little different? Got a thought, Allie?
We change like flip the x squared minus 9 to like match up
I actually would not flip the x squared minus 9. I like the x squared minus 9. I would flip the numerator around, is what I would encourage. Because we're used to seeing the x first, yes? And you may have been thinking a different way with this, but my encouragement is going to be, we're used to seeing x's first, right? Going in descending order. So if I flip around this numerator, instead of 12 minus 4x, what is this? Negative 4x plus 12 is what I would encourage you. Whether you write it down or not is up to you. But I would encourage you to think about that as negative 4x plus 12. Now, do you see any factoring that could be done in the numerator or denominator? 12 and 9 do both divide by 3, but what's the but here? 9 is married to the x squared, 12 is married to the negative 4x, because they're added and subtracted. We're not going to go there. We're not going to go there. We're going to keep it pure and simple here. Marriage means everything. I know. It doesn't quite work the same, but we're still going. We're still sticking with it. What do you see, Cyrus? Okay, x squared minus 9. That factors. Do you remember how? How does x squared minus 9 factor? Now? Do you remember 2 parentheses? Yeah. I know, common, yeah, they don't both have an x, so we can't do a GCF, but this is the difference of squares, right? It's 2 perfect squares being subtracted. So x squared breaks up into x and x. What's the square root of 9? 3. And if it multiplies to be minus 9, plus 3 minus 3? Okay, so watch out for that factoring, right? It's not always product and sum. Sometimes it's the difference of squares. Negative 4x plus 12. Notice there's no squared. So we're not doing 2 parentheses when there's no squared. What do you notice about 4 and 12? They both divide by 4. What's the factoring we're doing here? Is there a GCF? What is the GCF between negative 4x plus 12? There's a 4 of some sort, right? My recommendation, because the x term is negative, is to say negative 4. So if I do a negative 4 as my factor, what's negative 4x divided by negative 4? And x. And what's 12 divided by negative 4? Minus 3. And what just so happens to work out? There's a factor of x minus 3 that cancels. And again, you can, once it's all multiplication, you can do that. So what remains for our answer? Negative 4 over x plus 3. And any restrictions on the variable? X cannot equal negative 3 or positive 3. Anything that was ever part of that denominator has to be set equal to 0. So I'm going to say x plus 3 equal to 0, x minus 3 equal to 0, x cannot equal 3 and negative 3. Or if you'd rather, I don't know, did anyone write as x cannot equal plus or minus 3? You could write it like that. Okay, questions at this point? Okay, because we're ready to go into multiplying. But here's the deal, guys. If you can simplify fractions, you can multiply fractions. There's really not much more to it. Okay, so let's try and get at least one multiplying example out of the way. As you look at these multiplying examples, what's the difference from this example to the previous examples we were just doing? Not allowed to be scared. Instead of a 1 fraction, there are 2 fractions, right? Can you still factor and reduce, though? Yeah. Okay. And it's just like multiplying fractions. We can cross-cancel before we multiply. So let's start with the same steps. Factor and reduce. So let's do all factoring. 2x minus 8. Does it factor? Yeah. Notice there's no x squared, right? So it's not parentheses or anything. But there's a GCF. What do 2 and 8 have in common? A 2. So put a 2 out front. And then 2x divided by 2 is x. Minus 8 divided by 2 leaves me with minus 4. You want to go ahead and do the denominator on this fraction then? So right now I have 2 times x minus 4. Okay. What about x squared minus 16? Yeah, difference of squares we just did on the last one, didn't we? 2 parentheses. X squared breaks into x and x. The square root of 16 is 4. So 4 and 4. If it multiplies to be minus 16, we're going to use plus and minus. Okay? More factoring. Next fraction. X squared plus 5x plus 4. This is in the format to hopefully factor into 2 parentheses, right? We hope. X squared breaks into x and x.
So can we not cancel or make it 4 here?
We'll get there in a moment.
Okay.
What kind of numbers do I need in these parentheses? 1 and 4. They have to multiply to be 4 and add to be 5. So a plus 1 and a plus 4. Okay. X squared plus 8x plus 16. Also appears to be in the form where what? 2 parentheses. X squared is x and x. 4 and 4. Numbers have to multiply to be 16 and add to be 8. Okay. Carter was anxious. He wanted me to cancel already, and I was trying to get all my factoring done. Not that you couldn't have canceled. So, thoughts? What can cancel? Okay, so in the first fraction, an x minus 4 onto x minus 4 in the bottom can both cancel. And then, while we're at it, we can also cancel an x plus 4, yeah? Now, 1x plus 4 in the numerator, cancel with 1x plus 4 in the denominator. How many x plus 4s in the denominator do I have? Not 2. There's 3. Here's the point I want to make. This x plus 4, it can cancel with this one, with this one, or this one. Now, I'm canceling with that one just to make the point that one piece of the numerator of either fraction can cancel with one piece of the denominator, either fraction. I'm just trying to make that point. Does it matter which x plus 4 you cancel? No, as long as you're just canceling one. Okay, so what remains? In my numerator, and here's the idea, guys. How do you multiply fractions? You just multiply across, right? Numerator times numerator. Denominator times denominator. So to multiply this, we're just going to multiply across. What are my pieces that remain on top? 2 times x plus 1. I prefer that you leave your answer as 2 times x plus 1. My belief is that Math Excel does too. Now, could you multiply that out if you needed to? Yeah, you could say 2x plus 2, but I don't think you need to. What's left in the denominator? X plus 4 times x plus 4. What is x plus 4 times x plus 4? I mean, we could FOIL it out. What's the shortcut? X plus 4, quantity squared. This is how I would leave my answer. Now, if you're saying, oh, crud, I would have just written x plus 4 times x plus 4. That's fine. Well, at least, okay, let me rephrase that. That's fine in my book. I won't quote Math Excel because who knows, right? Okay. Notice, and I don't remember where all Math Excel asks this in homework, but notice there's one other piece we've got to do. State any restrictions on the variable. How do we get restrictions? Denominator equal to 0. Now, I would use the factored form. Notice, what pieces did we have here? We had an x plus 4. We had an x minus 4. We had another x plus 4. And another x plus 4. Those are all my denominators, yes? I kind of went overkill. Did I really need to write all 4 of those? No. Once you write 1x plus 4 equals 0, you don't really need to write the 2 others. Again, I'm just trying to make points here, okay? So what can x not equal? 4 and negative 4. Okay, guys. Tomorrow, we will pick up and do one more multiplication before we move into division. Homework, you are technically capable of a lot of the homework because the only thing you have to know from here on out, how do we divide fractions?
The opposite.
What do you mean the opposite of multiply? Officially, I should say multiply by the reciprocal, but a lot of you guys think keep, change, flip. Okay? So, you can get started on homework, but it will not be due till Thursday because I will finish notes tomorrow. Keep in mind that today is Tuesday, though.
My brother got some.